Good afternoon, Professor.
Afternoon. How's it going?
Song is good. How about you?
Oh,
How about
that's
you?
good.
Any plans for the weekend?
Uh, there is we do have an event here on Saturday, welcoming the new students. I'll be here for that. And then besides that, what's up?
Is that already?
Yeah. I mean, students have been admitted already, and so they're I think they have yet to commit, I think. So this is kind of like an event to one last push to convince them to come to Cal State Fullerton.
Professor, are you actually gonna read every single one of them
Every single what?
of our final projects?
The reports?
Yeah, you're gonna read it like everything?
Of course. What do you think I do?
You know what I would do, because I would just do like, I would look at the student, and if they're like A, I'd just put it like a random number generator between B and A. Like 1 and 2, and then just press random number, and just generate a random number. It's like 2, they get an A, there's 1, they get a B.
No, I read.
If they really want to contest it, they can come up to me and then I'll let you do.
No, I want to take my job first. I read every single one. I'm reading all of your individual essays too.
I would hate you as a professor.
And then if you would D, I would just do 1 through 6, and then you get lucky, you get an A.
No, it would make my job easier, but that's not. Yeah, I would get in trouble for that.
Well, how would they know? How would they know?
When a student goes up and goes, "Why do I have a D on this report?" and he doesn't have a real reason.
No, then you just go and you know, let me take a look at it. And you're like, oh, okay, I'll show you why, and then you just kind of
Make up reasons.
yeah, you know, well, the astral charts.
No, I read all of them. It's fun. It's fun. It's even the case studies that I've people have done in the past. It's still fun to kind of read new perspectives on them too. But there's the kind of reporting aspect of it. That's just the facts. But then there's also kind of the analysis that and discussion that you guys put too. And so it's interesting over the years how like kind of the same event has kind of been viewed slightly differently by people, just because current events have kind of changed people's perspective on some things too. Like one that evolves a lot is the whole social media data privacy thing. So almost every year there's a group that does that, but then the discussion and the report that I get is actually very different from that every single year. It's really
Do
interesting.
you compare it to the old ones?
Wait a second.
Like, do you read it and go, "Oh, I need to like read the old one again to see how different they are"?
I know I still remember every year kind of what kind of the main points were. Maybe not like all the exact details, but I still remember kind of the tone and kind of the main points. And so I kind of remember that each year.
Okay.
Hey, Professor.
What's up?
I have a quick question.
Sure.
I just got the notification for Canvas that said class attendance. Should we have came in person today, or is it okay if we're in Zoom?
No, Zoom is okay today. The exam's on Tuesday, so you have to come in person on Tuesday, but today's fine.
Okay, cool. I already scheduled the exam. I don't know if you got the notification.
I did. Yeah, I'm still working on the exam, so I'll probably upload it to once I'm done.
Make sure you make it easy, please.
Wait a second.
Make it easy, please.
I'll see.
Alrighty, thank you.
Your analysis on
Hmm?
Put some player analysis.
Well, we didn't win 4E in this class. If you're taking 308, then I would, but not in this class.
Throw them for a loop. Extra credit problem.
No. All right, it's 1 o'clock. Let's go and get started. All right, so good afternoon, everyone. How's everyone doing today? Good. All right, so we're on day 2 of our ethics discussion. So I think this is our first day of discussing ethics in total. So last time we spent the majority of the class talking about your final project. So and I did already get a few requests from groups. So it's good that you guys are doing it. If you want kind of a current status right now, there's 3 projects that are taken. There's the Boeing project, the Fukushima nuclear reactor project, and BF Goodrich have all been taken. So if you've already found a group and you're deciding, those 3 are off the table. But everything else is still good. Okay, so some announcements. Remember, Tuesday is our midterm exam, so make sure you guys are here for that. So remember, the midterm exam is going to take place in person, so you need to be here. Same rules as the last exam. So you can bring a writing utensil, cheat sheet, and a calculator. Okay. So I'm still working on the exam. I'm hoping to finish it up by tomorrow, and then yeah, we'll go and do that on Tuesday. Okay, so the plan for today is we have about half the lecture notes on the introductory lecture notes that I had on ethics, and then we're going to move on to our first kind of major ethics discussion, which is about risk and safety. So we're spending most of our time talking about risk and safety because that's the number one thing that engineers have to worry about is safety of the people that use the products. So we'll be spending today doing it and probably all of next Thursday as well. Okay. All right. Any questions I can answer before we get started for today? Okay. All right. So let's go ahead and get started. So Tuesday, like I mentioned, Tuesday we kind of introduced this idea of engineering ethics, right? Not only when you graduate and when you get a full-time job and you work at a great company, of course you're going to be expected to know all the technical skills that come with being an engineer. And honestly, the majority of your responsibilities are technical in nature, right? You got to know how to design things, analyze things, compute things, right? All the other stuff that you learn in your other classes. This whole course, 401 in general is kind of more dedicated to all of the other skills or all the other knowledge that you're expected to have as not only just as an engineer, but just as a working professional in general, right? So for the first half of this class, we spent a lot of time talking about economics, how that's important for companies because, in order for a company to pay you, they have to be profitable and all that stuff, okay? The other part is how to be an ethical engineer or just an ethical professional in general, right? And so we kind of introduced that idea last time, and we're going to continue on with that today. Okay? So I wanted to start today's discussion with what's known as the professional codes of ethics. Okay? And so the professional codes of ethics, what these are is, whenever you have a job or an occupation that's designated as a profession, right? And so you can have a job or you can have like a profession. Right? Engineering is defined as a profession, and one of the reasons why engineering is defined as a profession is that we have professional societies that set standards and set guidelines for how everyone in the profession should behave. And so, in fact, there are a lot of different professional societies, some of which you might be a part of already. Okay. So these are organizations like IEEE for electrical engineers, ASME for mechanical engineers, AIAA for aerospace engineers, SWEET, it's a Society of Women Engineers, right? These are kind of organizations that you've been familiar with, because a lot of these have student chapters, and so that's kind of how they recruit a lot of their members. That you kind of join as a member as a student, and you continue on as kind of a working profession. Okay. So as I'll be honest, when I was a student, I didn't really understand kind of the purpose of these societies. I thought it was just another club just for kind of socializing and getting kind of professional networking. But they actually do play a very important role for professional engineers in general. So their main responsibility for a lot of these societies is to set these kind of guidelines and standards for how engineering work should be conducted, how it should be performed. Okay. So of course, a lot of these guidelines, a lot of these standards are technical in nature, right? And so if you think about, you're designing a system, like let's say you're designing an HVAC system, ventilation, air conditioning for a building, you know, the society that sets the standards for, you know, how long your piping should be, how big the diameter should be, how much power should be drawn, what the pressure should be, you know, those are set by these professional engineering societies, right? Okay. So I'm just using HVAC as one example because HVAC is a field that's very heavily kind of regulated by the societies. Okay. But it's true for a lot of other things as well. Aerospace, you know, automotive, things like that. Okay. So probably at some point, you know, probably some of you have already kind of experienced, you know, these standards, and you've seen data tables or you've seen things like that. Okay. Another thing that these societies are responsible for is that they also put forth a code of ethics. Okay. And so just like the technical standards, you know, the codes of ethics are basically the way or how the societies think that you should conduct yourself, and how you should kind of do your work as an engineer to be ethical. And so when you're deciding or when you're doing, you know, especially when you're doing your projects, right? You know, if you read the rubric, or if you read the specifications for the final project or the individual writing assignment, you know, one thing that I tell you to do is to reference these professional codes of ethics, right? And so, you know, more, you know, for a lot of the case studies that you're going to be looking at, you know, what happened is probably, you know, most likely those projects violated at least one of these codes of ethics. Okay. So basically, they're kind of like your 10 Commandments, or they're kind of like your Bible for doing ethical engineering. Okay. And so, you know, let me pull some up. And so the two that I'm most familiar with, or I'd say there's one I'm most familiar with. That's the one I kind of learned at school, which is the IEEE Codes of Ethics. Even though IEEE is primarily, you know, it's an electrical engineering, you know, society. You know, their standards and codes of ethics is actually used by everyone, just because a lot of what they say is considered ethical work applies for all engineering. Okay. So IEEE is a good one to start with. Just because it's fairly compact, it's fairly kind of you know, efficient and kind of short. Okay. The other one that's a lot more thorough, just because this society kind of is responsible for all engineers, is called the NSPE. Okay. Which I think stands for, I always forget what it stands for. So NSPE stands for the National Society of Professional Engineers. Okay. So NSPE also has a code of ethics. It's very thorough, and therefore it's a lot longer to get through. So there are others, you know, most engineering societies have their own kind of codes of ethics. And so ASME has one, AIAA has one, but these are the ones I'm kind of most familiar with. And honestly, you know, there's a lot of overlap between a lot of them. So, you know, the ones that I generally like to kind of focus on in this class are just kind of these two. You have one that's kind of more digestible, shorter, easier to understand. And you have one that's much more comprehensive and thorough to kind of handle a lot more niche situations. And so with that, now let me go ahead and share my screen. So I did pull both of these up. We're not going to read through all of them, just because they're very, very long. But basically, if you just Google search, what I like to do is I just search IEEE Code of Ethics. And so you go to the site, okay? And you can kind of read their codes of ethics. So you can see the IEEE one is very short. So it's barely any scrolling involved here, right? But you can read some of these that, that as a member of IEEE or as a professional engineer, you're responsible for upholding the highest standards of integrity, responsible behavior, and ethical conduct in professional activities. And part of that is to hold paramount the safety, health, and welfare of the public, to strive and comply with ethical design, sustainable design practices, and so on and so forth. Right? So I'm not going to read all of them just because it's going to take forever. But I'll go ahead and link these on the website just so you can take a look. It's definitely something that's good to read. Right? So we won't be going through each of these, but throughout the discussion of the course, for the rest of the class, we'll be covering kind of the main topics of kind of each of these standards. Okay. So I wanted to bring these up because these are definitely a really good reference for you to know, as you're kind of reading about the case studies and seeing and kind of analyzing how the actions of the people in your case studies violated or followed some of these standards. Okay. So here are the NSPE codes, code of ethics right here. So you can see it's much longer. So there's a lot more involved here, a lot more scrolling, and you can even download a PDF version of this. But what you'll see is that the NSPE code of ethics, they follow all the same things, and so there's nothing new in this one. It's just that they are kind of a little bit more detailed, whereas the IEEE one can be a little bit general and a little bit broad. Okay, but both of these are great references, and so I definitely recommend you check both of these out. As we kind of as all these topics kind of come up in our discussion class. Okay, let me bring back the. Okay. Oops. Okay, there we go. And so, you can kind of make the argument that, what we're essentially doing in this class is we're kind of taking those codes of ethics and kind of just expanding and kind of discussing each of those different topics that they go over. Okay. So, what are these, or how are these codes of ethics used? Because of course, these codes of ethics, they're not really like a, I think people kind of liken these together to like the rules of your company, right? So generally, if you work for a company, the company has its own rules, and if you violate those rules, you can be disciplined from them, right? The codes of ethics are not exactly like that, and so it's not that your company will discipline you if you violate these rules, right? The societies don't have that much power. Though, so these standards, these codes of ethics are, you should not really see them as kind of like a hindrance, because I think people when you first read these and you're like, oh, these are model rules that I have to follow, but these rules are actually designed to help you. So of course that sounds very kind of cultish, right? So we wrote all these rules, and these rules are there to help you, right? But they're here to help you, for a very important reason. Because a lot of times, when you're kind of conducting yourself professionally, you're working for a company, it's not you that wants to violate these codes of ethics, right? Usually it's your company that's going to ask you to violate these to kind of put safety aside, put profitability up there, or maybe to do things in not a very ethical way, right? And so in those situations, when your company is asking you to do something that you may not be comfortable with, you might find it hard to kind of find kind of the, I guess the something to kind of back you up into kind of being an ethical person, right? So these codes of ethics are designed to kind of help you in those situations where, if your company is asking you to do something that you may not be comfortable with, you can bring up these codes of ethics where, you can say that, you don't feel comfortable because, these codes of ethics, these go against that. Okay. Okay. Because these professional societies, at the end of the day, these professional societies have a lot of power, right? And so if you're doing work, or if your company's asking you to do work that kind of violates their codes of ethics, then that company is risking kind of, having these professional society not endorse them, or not kind of, sign off on the work that they do. Okay, because these societies, like we mentioned before, they're also responsible for setting a lot of the technical standards that are used in a lot of work as well, right? And so if these companies kind of get on the bad side of these societies, that's also kind of bad for the company as well, right? So these codes of ethics are very useful to know, and hopefully by the end of this course, these codes of ethics is something that you are familiar with, so that you can kind of take it with you to your professional life, and you can use it. Hopefully you're not put in a position where you have to use it to kind of defend yourself, but it is there for that. Okay. All right. Any questions on this? Okay. So professional codes of ethics, definitely very useful to know. Okay. All right. Let's go to a little bit more abstract. So let's talk about kind of just ethical and moral theories in general. Okay. So while I would say the professional codes of ethics, that should be kind of your first reference in guiding you to make ethical decisions. There's other kind of general theories or ethical kind of frameworks to kind of help you as well. Okay, so these theories here don't carry as much weight as the professional codes of ethics. The ones that are kind of following these are kind of like ethics departments, and they don't have as much power in the engineering world. But they can help you kind of sort out, maybe a very complex situation where you may not be sure what the most ethical or the right choice to make is. Okay. Okay. All right. So the first one that we'll go over is a concept known as utilitarianism. Okay. And so utilitarianism is a moral theory that strives to maximize the well-being of society as a whole, rather than maximize the well-being of certain individuals. Okay. So it sounds great, right? And so it kind of sounds like kind of what all work should be doing, right? And so as a whole, we should be striving to kind of improve the life of everyone. But it can get complicated. And so, I think when you first kind of read this statement, and I think people kind of think of certain types of individuals that, they could maybe sacrifice a bit more to save for everybody. But a lot of times, situations where utilitarianism come up are not as kind of straightforward. So let me give you an example. So let's talk about the construction of dams, right? So dams are these, these facilities that are designed to kind of make use of, kind of the natural kind of power of running water, right? And so everyone's probably seen the Hoover Dam at some point, if you may have stopped by there on the way back from Vegas, but there are these kind of massive facilities that kind of make use of kind of, a river or any kind of, a stream or something to kind of generate power and kind of maximize the safety of the area around it. So generally speaking, people view the construction of dams as a good thing for society, right? So they provide a lot of benefits to kind of the society and community as a whole. Okay. So some benefits are things like flood control, drinking water, and power. Okay. Sometimes they also provide a tourist attraction, just like the Hoover Dam does. Okay. But of course, this comes at a cost. Most of these projects are publicly funded. So of course, we have to find the tax dollars to pay for something like this. But constructing the dam is also not, not a straightforward process. Right? So if you've ever, if you ever live near someplace like this and they've decided to build kind of a very large kind of public construction, more likely than not, they've either asked you to relocate your home or to give up something in return. Okay. Because either maybe the heavy machinery, or maybe just it's a safety concern, or maybe there's some local flooding that can occur. Usually a big public project like this requires people to relocate, right? It's the same. It's the same. If California wanted to either expand a freeway or build a new freeway, build a new rail track, right? Probably some people are going to have to relocate and kind of move their homes. Now, of course, the ideal thing would be, maybe the government kind of compensates these people. They help them kind of they buy their home and kind of help them buy a new home. But it's never really, as kind of straightforward as that, right? And you may have situations where, maybe you have a family that's been living in a certain place for generations, right? And so asking them to kind of give up their home for something like this is, it's tough, right? And it's not always clear kind of, what's the right thing to do, because those, maybe you have a family that's been there for a very, very long period of time. So this is a case where building a dam, building something like this, it would be a general good for society, but you're asking certain individuals to kind of sacrifice a lot for it. Because even though utilitarianism, I think, sounds nice as kind of a concept, but having certain individuals sacrifice for the good of society, right? But oftentimes it's not really how those individuals that have to sacrifice, how that group of people is chosen is not always the fairest is not always the fairest thing, right? And so think about, maybe if you or yourself or your family were being asked to sacrifice, give up your home or pay a lot of money, for something that's going to be deemed a public good, right? It wouldn't be fair, and it's definitely a complicated theory. It's a theory that sounds nice, kind of in broad strokes, but when you get down to some of the details, it can be definitely very challenging. All right. Any questions on utilitarianism? Okay. All right. So next one I want to go over is called the duty ethics. Actually, no, these come together. So it's called duty and rights ethics. So duty and rights ethics is a moral theory that basically states that, as a society, we have a responsibility or we have a duty to protect the individual rights of everyone, within that society. Okay. And what those rights are things like, the right to life, liberty, and property. And it's all of our collective responsibilities to protect those, not only for ourselves, but for everyone else in the society as well. Okay. So it's a very American type of moral theory. Right? And so any action that is taken to kind of limit or kind of hinder these rights from people is seen as unethical. So as an example, just a very, very simple example, right? So let's say that you're a car manufacturer. So let's say that you work for Ford, and your Pinto exploded, right? And it caused a lot of harm to something. Right? So maybe the person is fortunate enough not to lose their life, but maybe they come out of this with a very debilitating injury. And if in that situation, if the car manufacturer were found liable, so maybe it's a design defect or maybe an oversight that they knew about, but they didn't address in their design process, then they would be unethical from a duty and rights perspective. Okay. they'd be violating or it'd be unethical from a duty and rights perspective because they're hindering or limiting this person's ability to kind of experience life. Okay. All right. So these are kind of two ethical theories, and if you kind of read between the lines a little bit, you know, if you compare utilitarianism to duty and rights ethics, they're often at odds with each other, right? And so while utilitarianism, we're kind of focused on kind of benefiting society. So oftentimes that involves kind of hindering or limiting the rights or freedoms of certain individuals, whereas duty rights ethics say we should protect these as a society, right? So which one do you follow? Well, I'm not here to tell you that, right? So it's not a you should follow one or the other, and hopefully I didn't present these to you as one is right or not, because there are definitely situations where one is right over the other one, and then vice versa as well. So the reason I'm kind of bringing these up to you, and I have one more after this as well, is that these are kind of like these are just serve as guidelines. Okay. And so they're not exactly rules to follow. They're not exactly kind of hard things to guide every single one of your actions. But they're kind of guidelines that kind of help you kind of maybe analyze or maybe pick apart a situation that you may not be sure what the right thing to do is. So you can use utilitarianism. How would I look at the situation from a utilitarian perspective, or how would I view the situation from a duty rights perspective, to kind of help guide you in finding an answer or finding an ethical solution that you feel good about. Okay. And so when you go do your case study report, I expect to see some discussion there, right? Because on the one hand, you may look at a situation that in your case study that an engineer or a manager did, and you'd be like, I actually kind of agree with this, because if you look at it from a utilitarian perspective, or you look at it from a duty of rights perspective, they were trying to kind of achieve some good. And of course, something bad happened. Whereas on the other hand, you could make the argument that maybe what they did, if you look at it from a different lens, from a different moral theory, was actually kind of a bad thing as well. Let me give you an example. We're gonna have lots of story time in this section of the course. It's a lot of case studies, but I think that can happen. Okay, so we're going back to 1984. Okay. There was a huge disaster at a chemical plant in India. Okay. It happened in the town of Bhopal in India. Okay. Basically, what happens is that there was a tank that was storing a lot of toxic chemicals, highly pressurized, highly dangerous toxic chemicals, and there was a pressure relief valve that kind of broke, and it kind of spewed toxic chemicals all around the surrounding area. And so it led to a lot of the residents in the area getting exposed to these chemicals and developing conditions and getting sick and things like that. Okay. All right. So it was a big disaster. So, thousands of people were killed and many more were kind of left sick or permanently disabled from. So, you look at a situation like this and, and I think people's first reactions is, why is there this highly dangerous chemical plant being built, in such a kind of a densely populated area? Because this area of India was known for being kind of very dense and populated. A lot of places in India are kind of like that as well. Because if all it took was just kind of one valve failing, in order to kind of have a disaster of this magnitude, if you've ever kind of worked on such a huge kind of engineering system, components kind of fail and they kind of get worn out all the time. And so if a single valve can do this, then why is that why is that an acceptable level of risk with that many people around? Well, when you have a big plant like this, it requires a lot of people to work there. And with kind of the public transportation infrastructure, it was difficult to find all the people for that without kind of building it kind of near where they lived, which is kind of, it was kind of built next to their village. And of course, the people who designed and built the plant, of course, didn't plan for it to fail, right? And in fact, the plant was built there mostly to kind of help the residents. In fact, prior to this accident, the plant was generating kind of a lot of revenue and a lot of jobs for the people in the area, and it generally kind of raised the quality of life of people there. And so from that perspective, this project or this plant kind of passed the utilitarianism test, where it was in general kind of providing a lot of public good for the area, a lot of wealth and a lot of productivity, higher standard of living in general than prior before um, before the accident occurred. Okay. Of course, they investigated the incident and they found that a lot of the safety standards and a lot of the maintenance was kind of being neglected in the plant. Um, and so that's kind of what ultimately led up to the valve failing. But it's an interesting kind of thought that you on the one hand you have this tremendous risk, right? This plant that's kind of producing a lot of these toxic chemicals that's putting a lot of people around it in danger. But on the other hand, if everything goes well, it provides a lot of good. And so, of course, most times we only see kind of one side of this argument because the disaster did happen, but there's kind of multiple different perspectives from kind of looking at the situation. All right. Any questions on this so far? Okay. There's actually a case study for the final project that's actually very similar to this. We talked about it on Tuesday, which was the Love Canal. So I'd be very interested actually if a group picks that up. I think last year no one picked it up, but that was a situation where they were trying to build a lot of new housing in kind of the New York, New Jersey area. Because housing availability is always kind of an issue in this country. And so they built it on top of an old kind of toxic waste dump. And so they were able to build a lot of affordable housing there, but they didn't realize that the toxic chemicals were not very well contained. And so a lot of people got really sick, and a lot of people, developed really terrible conditions. And so, what price, it kind of raises the question of what price are you willing to pay for kind of affordable housing, which, may say a lot of other things about kind of our society as well. Okay. So the last type of ethics, or the last moral theory that I want to go over before we move on is virtue ethics. Okay. So virtue ethics is a moral theory that's centered around the kind of the concept of virtues and what a virtuous person would do. Because there are certain virtues, or I'd say kind of certain personal traits that we all consider to be, most people consider to be good. So there are things like honesty, responsibility, competence, loyalty, respect, right? Okay. All generally seen as kind of very positive characteristics for people to have. Okay. Now, granted, these are characteristics of people, right? Generally, with engineering ethics, we're talking about the ethical kind of character of actions, right? So we're not getting into personal attacks here. We're deciding whether certain actions or certain decisions were ethical or not. Okay. So the idea with virtue ethics is to kind of correlate these two things. So virtues are positive characteristics that we apply to people. We in virtue ethics, we use them to characterize certain decisions or actions. Okay. So you can say, whether an action is honest or whether a decision was responsible, things like that. Honestly, a lot of the discourse that's thrown about in the media nowadays is kind of based on virtue ethics, and so they use kind of certain decisions that people make. They characterize them as with these personal traits like honesty, responsibility, loyal, things like that, and then that gets correlated then to the person's personal traits. And so because so and so did such an action, so and so is a terrible person, or because so and so did a good thing, that means they're a really responsible and really honest, really loyal person, right? So it's a fine line, and it's not something definitely you have to be a little bit careful applying this theory just because I think a lot of times when people apply virtue ethics, kind of unintentionally. That's kind of just how our brains are kind of wired. But when you start to get into kind of personal traits and kind of personal attacks on people, that's the worst thing. That's when kind of things start to break down. You're no longer talking about engineering. You're kind of having a pissy fight, I should say. But it can be useful. It can be virtue ethics can be useful tool in certain situations. When you're kind of maybe analyzing your own actions in terms of is this consistent with my own virtues? Is this consistent with my own standards of kind of how I set for myself? All right. Any questions on this? Okay. All right, so that kind of concludes kind of the introduction to ethics. And so, the main things that we kind of went over here is just kind of the purpose of kind of why we study ethics in general, and just some of the general tools that you're going to use to assess or to analyze whether certain actions are ethical. Okay, so we have the professional codes of ethics and the moral theories. All right, so from here on out, we're going to go into certain kind of smaller topic areas, so kind of certain areas of engineering ethics that are particularly relevant for engineering. Okay. So the first one that we're going to talk about is this concept of risk and safety. So risk and safety is kind of the most important thing. And no matter what engineering code of ethics that you read, IEEE, NSPE, AIAA, ASME, right? The first thing that they always mention is just safety of the people, safety of society, safety of everything. Okay. So it's the top thing, right? And it's the number one thing that that engineers are responsible for. Okay. So as engineers, our first and most important responsibility is to protect the health and safety and well-being of people. Okay. Not only the people that use our products, not only the people that are directly affected, but also just kind of the larger kind of wide-ranging effects as well, right? So some of what we talk about today can also be extended to environmental ethics as well, right? Because things that affect the natural environment are going to affect people, maybe not today, but maybe down the road at some point. Okay. Although we have a separate unit on environmental ethics as well. Okay. All right. And so the main reason for this, besides being kind of obvious, is that the main reason that when people use your product, they pay money, they buy a phone, they use their car, they use an elevator, right? There is an assumption that whatever they're using is going to be safe for them, and it's not going to put them in any danger. Okay. And in fact, a lot of products and a lot of projects that engineers actually do work on, their whole purpose is to enhance your safety in certain situations, right? Things like a bicycle helmet, things like a lot of the safety features that you see in cars nowadays, right? And so, that's kind of the expectation, right? Of course, like we mentioned on Tuesday, that not everything can be 100% safe all the time. Okay. It's impossible to eliminate all risk in a situation. Okay. Like we mentioned on Tuesday, just getting in your car every day, right? No matter how much engineering, how much safety and how much a car is prioritized for safety, it's impossible to eliminate all the risks that are involved with driving your car, right? But so it's not, when I say that it's the engineer's professional responsibility to protect the safety of the people. If something goes wrong, that doesn't necessarily mean it's the engineer's fault, right? Because it's impossible to eliminate all risk. Okay, even just standing here, that ceiling panel could come down and kill me at any time, in theory, right? So that's the risk that I'm taking. That's the risk that you're all taking by being in here, right? So it's not that we have to eliminate all bad things from happening, right? Um, so our job is not to prevent all these bad things. That's impossible. Okay. Our job, therefore, is to, try to instead try to maximize safety and minimize the risk as much as possible. And there's ways to quantify risk, and there's ways to kind of quantify safety. And so, safety and risk, I think people talk about them a lot as these kind of like nebulous kind of abstract concepts, but there are ways to quantify it, and we do have a lot of methods for doing so. You've probably already seen some of them in your classes, right? And so things like factor of safety, there's ways that we can quantify that. Okay. And we'll talk about more methods in the class here. And so, it's taking those metrics, taking those quantifiable metrics and making them as good as possible. Okay, so let's define some terms. So I've been using this term a lot, but let's kind of put a formal definition of it. So let's define the word risk. So risk is defined as the probability or the possibility of danger or harm. Okay. Oftentimes, risk is presented as a probability, as a percentage chance. Okay. That's probably the most clear way to express risk, is that, when you're doing this thing, you have like a 10% chance of getting harmed, or you have a 10% chance of so-and-so happening. Okay. But even the possibility, even if the probability of a certain certain thing occurring, even if that's kind of vanishingly small, the fact that it is possible that certain things can happen, that's characterized as a risk as well. And so like that chemical plant in India, right? And so, probably the percent chance of a valve failing, if all the maintenance is done correctly is very, very small, probably less than, 0.001%. But the fact that it was a possibility for that valve to fail, that's a risk that must be accounted for, when you're doing your engineering. Okay. And so the other side of the coin is safety. Okay. So safety is defined as freedom from damage, freedom from injury, or freedom from risk. Okay. And so if you're in a situation where you don't have to worry about damage or injury or risk, then you are in a safe situation. All right. It sounds simple, right? And in fact, I think as you read, as we cover more and more case studies, safety and risk is something I think, even though I think everyone recognizes that it is very important. I think it's something that a lot of people kind of, to a certain degree kind of brush off because it seems just very straightforward, right? And so, not to design products that can put people in life-threatening situations. When something bad happens, it just seems so obvious. Like, oh yeah, like of course, Ford shouldn't have put that gas tank there. Obviously that would have caused an issue. But there's layers to this, and there's a lot of nuance. I think I want to make sure that that we cover. Because like I mentioned, no matter what, right? If you use a product or if you do anything more in your day rather than just lay in your bed, you're putting yourself at risk for things. Even if you lay in your bed, there's a risk that your bed might fall apart, right? So there's a risk with everything, right? And so of course, there's certain trade-offs or there's certain ways that we view risk that make things acceptable to us. Okay. And that's a concept that we're going to work our way up towards is just what is defined as an acceptable level of risk that we can tolerate for ourselves and for our clients or customers. Okay. So the first concept is this idea of voluntary versus involuntary risk. All right. So what we perceive as safety, or what people generally perceive as a safe situation, can be, can be made higher if all the risks are known ahead of time and voluntarily accepted. I should say safer. Okay. Maybe the actual situation hasn't actually changed in so if you're in a situation where you have to sign a waiver for something, right? The fact that you sign a waiver doesn't make the situation safer or less safe, but it can be perceived as safer if you know all the risk, right? Because I think one thing that most people are afraid of is unknown, right? If you're going into a situation and you don't know kind of what's going to happen to you, if you don't know kind of what the harms may be, then that's going to naturally going to put you more on guard, right? Because you have to kind of be prepared for anything. But if you're entering a situation where those risks are kind of laid out to you, they're explained to you, you understand them, then it can be perceived as safer in that situation, even if the situation hasn't gotten any better or worse. Okay. So of course, the most common example of this that you see in practice today is the concept of a safety waiver. Okay. Okay. So if you go to a certain type of attraction, you do a certain thing, like maybe say you're rock climbing for the first time, right? If you're rock climbing for the first time in a certain facility, chances are 100% chance, the facility is going to ask you to sign a waiver so that you can't sue them if you fall and break your back, right? So the whole idea with these safety waivers, nowadays no one really reads them, but the whole idea with the safety waivers is to kind of inform you of the risks so that you can kind of voluntarily accept it, right? So that you kind of know what to look out for in that situation to make it safe. Okay. Okay. Next kind of nuance is the difference between short-term versus long-term consequences. And so if you have a situation that carries some risk, right? If the consequences are only going to take place, or it's only going to affect you for a shorter period of time, you know, that's generally perceived as less risky than a negative consequence that can affect you for a long time. Okay. Okay. Even though the definition of risk has absolutely nothing to do whether, the consequences are shorter or long term, generally speaking, people view, shorter term consequences as less risky. Okay. Because it's this idea that, maybe if something bad does happen, but if you can recover from it, that's seen as more acceptable for people than, rather than something that maybe you get an injury that's going to affect you, for 10 years or something like that. Okay. So that's kind of another kind of nuance, right? Even though it's not in the definition for risk, but it is a factor that people think about. All right, number three. Number three is this idea of expected probability. So the idea with expected probability is people kind of try to play the game of how likely is this actually going to happen, right? So if a situation carries risk, but the probability of that risk happening is low enough, then people are kind of likely to ignore it. Okay. And what's interesting is that, if the expected probability is low enough, people don't even consider just the severity of the consequences. Okay? And so, if you have a situation where you have, maybe a negative consequence has a very low chance of happening, but the severity is very high. Versus another situation where you have a situation that has a fairly high probability of occurring. Okay. It's a very high probability event, but the severity or the consequences of that negative event is very low. Okay. And so in these situations, if you ask people kind of what they perceive as more risky, they're going to choose the second one. Okay? And if given the choice between the two, right? And so if there was a choice between these two, they would certainly choose. Most people would choose the low probability, right? Even if something bad did happen, even if it's a very severe thing, they would see the other one as kind of less risky. Okay. So that's another thing to kind of keep in mind is that no matter sometimes people think about kind of the short-term and long-term consequences, but sometimes people just kind of see it as something bad happening versus something not bad happening, right? And of course, there's different levels and there's different variants to this as well. And so if you give people a situation like this where you have a high probability of something going wrong, but it's a very low risk, it's a very low severity thing, you can recover for it. They probably see that as more risky than something else. Okay. Okay. Number four. Number four is this idea of reversible effects. So this is kind of similar to point number two, where if you do have a negative consequence that occurs, if it's possible to reverse it, if it's possible to recover, then that's seen as less risky. Because it's this idea that even if a negative event did occur, you can still kind of return back to where you were, if it's reversible. Okay. You're more likely to purchase that thing, even though it has a high risk of being maybe a little bit sus or maybe not so reliable. But if you can refund it or if you can get a full refund, then you're much more likely to kind of purchase that thing because it's seen as less of a risk. Okay. All right. And then number five. Number five is a delayed versus an immediate consequence. So if you have a situation where the consequence or the negative effect of a risk is delayed, and so it's not something that's going to occur right now, that's going to be seen as less or perceived as less risky than not. It's something that may harm you right away. All right. So there's a lot of nuance, and it's not only not only nuance in terms of the definition of risk, but it's more nuance in how people perceive it, right? Because people's perception of safety is actually a very important part of the marketing, a very important part of the sales of a product as well. Right? Right? And so it's important to kind of keep these in mind as you kind of design your product, right? And so maybe if you have a situation, you're designing a certain product, do you design your product? Do you kind of try to minimize the risks overall, or maybe you design your product in a way that minimizes the immediate consequences. Maybe you would design your product to just accept that there's risk, but to minimize the severity of the consequences. Right. So there's a lot of different ways that you can think about safety and risk as you design your project, and it's going to affect a lot of the decisions you make along the way. you know, and always remember that, you know, as we kind of talk a lot about these ethics, right? You know, ethical considerations are always important, but remember, they're not the only consideration that you're making for these products as well. Because at the same time, you know, you're trying to make your product, you know, profitable. You're trying to make it, you know, sound and efficient on a technical perspective as well. And so, you know, when you're just examining the ethics of a situation, you know, especially when you're doing your case studies, a lot of times it's very clear, like, oh, that's unethical or that's very ethical or things like that. But just remember that, you know, there's a lot of other considerations as well. And oftentimes, you know, when you make a decision, you know, there's no right or correct answer. And so you're going to try to satisfy as many criteria as possible during your work. Okay. All right. Any final questions for this today? Okay, so it's a little bit early, but there's the next part's kind of a big long thing, so I'll save that for next Thursday. So remember, next Tuesday is our midterm exam, so please make sure you're here for that. Make sure you're here on time. You know, the exam will take place over the lecture. Okay. So hope you guys have a good rest of your weekend. If you have questions while you're studying, definitely feel free to send me an email, and I'll get back to you as fast as I can. So I don't have any more. I do have office hours on Monday, actually. So if you have any questions, you can come for that as well. But email is definitely open. So thank you guys for coming this week. Hope you have a good rest of your day. Hope you guys have a good weekend, and I will see you next week.
Have a good one.
Oh, no, I'm just getting hands out.
Have a good weekend, man. You too.
Yeah. That's like we heard the one for the next one. I think it's just like I might and then that's in the car later.
I saw someone on Discord.
It was 16.
So,
I know that it's like
were you on Discord? Oh, I can try to.
I have next Wednesday. But I'm doing the recruitment myself, so I don't have to do it. I just take the department. Yeah.
What's still open for the project?
Most of it is still open. The only ones that are taking are Boeing. BF Goodrich is taken. That's the break issue with the Air Force ones.
Oh, okay.
And then the Fukushima nuclear reactor has been taken. But everything else is still open. And of course, you can come up with if you know of another case study that list is not exhaustive. And so if there's another case study, then that's fine too. Just run it by me. As long as it involves a primarily engineering company, then that's fine with me.
Professor, it's email, right? Just send you an email.
Yeah, email.
Okay.
Preferably if everyone's on the email, it should at least have all your names.
Okay.
And then just let me know your top preferences.
Top three or
three is good.
Okay.
But because I did see that a couple of people emailed me during the class, so I haven't had a chance to read them. But
okay.
So top three would be good.
All right. Thank you.
Yeah. Mm-hmm.
And it's technically due by the 21st.
Yes. Yeah. 21st.
Isn't there another thing like our project agreement?
Yes. So the project agreement is basically that. So you choose your topic, you choose your group, and then also the individual writing assignment is due that Sunday as well.
Oh.
Yeah.
Oh, okay.
It is. It's.
Yeah,
I have one more question. I asked you about the last class.
Yeah.
Where if you need it, if you're taking out another CC and transferring it, where do you get the paperwork if it's a prereq for one of the
There's an online form for it, so it's a Google form. I'll email it to you after the call.
Okay, I'll email you.
Yeah, if you can do that, that'd just remind.
That's great.
Yeah, it's just a hydro.
Yeah, I was looking earlier this week, and I'm like, oh, I have my registration date's Friday. I don't know how this is going to work.
There's been a lot of permits coming in, so yeah, make sure you get it in, because they're, yeah, we want to make sure we process it.
Thank you.
Yep.
I knew that was gonna be my. No, that's not what I'm about.